Thank you, ladies and gentlemen. I speak a bit of French because my wife speaks French. So every day I have to say something to her very nicely, like bonjour, bonjour, merci, after she cooked dinner, and then at night before we say je t'aime beaucoup. Yeah, something like that. Yeah, she understands, but never mind. So other than that, I don't. So I will try to speak Chinese. That sounds like English. Okay, so if you don't mind, that you can bear with me. I'm going to talk to you about a few of our projects. They are hobbies, because my real job as a professor is in urban environment. So this is really hobby for me. I do it for fun, so no money. So I have to get donation from people and then work with people who have nothing to do like me, and then go to somewhere that nobody goes to and do something interesting. Now this is China. As you probably know, China is quite big, but then it has also a lot of problem, and especially in the rural environment, half of our population still live in the rural environment, and some of them in very poor environment. So these are some of the problems as we study the village, environmental one, social one, and most of the time economical one. The village's annual income is about about 200 US per year. Okay, that's how much they earn. So whatever you do to them, it has to be very cheap. And they also have a problem of the environment, because like Peru, they can't afford things, therefore the houses are always very cold. And I'm going to show you 3 projects that we have done that demonstrate some of our approaches. And 2 of them are in the southwest of China, and 1 of them is the northwest. Northwest is very dry and very cold. Southwest is not that cold, but it's very wet. So the type of soil you get is very different. Up there, things are a little bit more clay-like, but down there is normal kind of red soil. Okay, so this is the first project that we work on. This is the final product in the northwest of China. It's very dry and also very hot in the summer and very cold in the winter. This is the one picture that summarizes the situation. The villages are down there, 500 meters down, where the river still runs. The original land is here. But since the soil eroded away, so the river slowly cut through the soil, and now the village is down there, 500 meters. So you really have to go down. But the ground level used to be like this when they still have forest, but now no more trees. And these are some of the buildings that they have, like caves. They actually dig into the ground and dig into the ground, and they don't build, they just dig. So this is one of the caves that they dig, to be used for school. And then lately, some of the richer Chinese built this kind of school, which is inadequate. They are very, very bad environmentally, very cold in the winter, extremely hot in summer. So students doesn't like it, so students prefer to go back to the cave, which is very sad. So we go down there and see whether or not we can build a better school. This is the climatic conditions, as you can see, very dry. Very hot in the summer and very cold in the winter. Plenty of sun. These are some of the houses they are building. As you can see from the ground, they dig down and then they dig sideways from the courtyard. So they first of all they dig this, and then they dig sideways into the soil to make houses or make homes, like the diagram up there. Sometimes they build with adobe, which you can see on the other side. But lately, a lot of the houses are built in brick, so they are not very good. So we did a number of studies to see what we can do, from very simple improvement of the material to more sophisticated use of passive solar, as well as ventilation strategies. We actually use this diagram to guide our action. This is the performance gain. So higher, the better performance in terms of environment. This is how much it will cost. So you can see that actually for 20% more than they are building, you can actually get very good performance. But after that, if you want to get more performance, it actually has a lot of costs related to it. So we actually decided to build a house to that level of performance and not to that level of performance, because otherwise it would be cost too much. So this is the guiding factor between environment and also the cost that you can afford. And so this is the foundation of the school that we are building. The rocks are there, and then on top of that you have adobe bricks or blocks. We had the same problem that you mentioned, that the blocks are big, and then when we ask them, they give us a different answer. We say, why do you make such a big block and it's so heavy? The farmer look at me and say, no, they are not heavy. They are very strong. So I say, so we keep quiet. So our students are very small, so they're very big. So they make 5 of them like this. Our student, 2 students, 1 block. So never underestimate farmers. They are very strong. This is how they lay the wall. We designed the wall to be very thick, about 800 millimeter thick. The reason for that is we calculate that with that thickness, the temperature inside is independent of the temperature outside. So it's a thermal mass. And since the mud is very cheap, so we can afford to build as thick as possible. So our calculation indicates that it is about 800. And then for structure, for seismic resistance, we actually have timber in the mud to hold the roof together. So, and this is again the straw that we use as roof covering. And this is the final product. As you can see, the trees are yet to grow inside the small courtyard. The bigger courtyard is for the winter, and the smaller courtyard is for the summer. So this is a smaller courtyard. All the windows, the buildings are facing the south, has big windows and higher ceiling, so that they have thermal benefit into the classroom. Okay. So this is how the classroom looks like nowadays. As you compare this with the earlier cave buildings, you can see that the lighting conditions and also the internal conditions are better. The height is very high because we calculate the ventilation needed for 1 class. Okay, so every hour the student will go in, they open the door, so the fresh air comes in, fill the room, and then they stay there. Because of the volume of the air, they will be all right for 1 class, and then they go out and open the window or open the door. So the volume is much bigger than it used to be because of the need for ventilation. So it's enough fresh air for 1 class. And also these windows are small, therefore the bigger volume gives you better daylight, especially if you put the window high up. It gives you better daylight for smaller window to keep the warm and also get you better light. So this is the environmental needs for the design. And we actually did some measurements and find that the outside is like this. Every day they go, this is the winter, it can go down to about -5. And in daytime it's 10 degrees, so it goes like this every day. But then the inside temperature stays almost same. So it's quite not comfortable, but it's not bad as -5. It's about 5 degrees when there's no student. So we use the student to heat up the room. So when the students are inside, it's about 10 degrees, which is quite good. And because of that, they don't need to burn coal in the classroom in the winter anymore. So the headmaster was very happy. Because in the past, when they burn coal, they close the window. Sometimes students die of carbon monoxide poisoning because they didn't realize that it was poisoning. So now they don't need to burn coal, so they are safer. This project actually are quite well known and won a number of very big awards, like the World Architectural Festival and the RIB International Award. So to demonstrate that actually we can do this very cheaply to solve a very difficult problem. Next project I'm going to show is a village that was completely destroyed during the earthquake in 2008. And this village, there's no road, so you can't go there by car or whatever. You can't ship anything into it. You have to climb over the hill 2 days to get in there. So, and there's nothing, no material. So the government asked us to rebuild this village with only materials on site, nothing else. We managed to bring a few beds of lime into it, but that takes a lot of effort. So this was what we call the 512 earthquake, a big earthquake in China. About 15 million people were affected. And we are only working in one of the many villages that was destroyed. This is in the southwest of China, in Chengdu, at that map there. You can see the Ma'an Chao. That's the position of the village. And the government actually did something because they don't know how to do it. Therefore, they ship in a lot of modern techniques and modern materials and built in a kind of a reinforced concrete way. The problem is if you build it this way, it costs you a lot of money, approximately 100,000 local dollar. But bear in mind that the average household is $1,000 every year. So you will take up a mortgage that you cannot repay for the rest of your life. So although the government tried to use these better techniques, the villagers doesn't like it because they can't afford it. So we went in to see whether or not we can build a house that only costs 2,000 instead of 100,000. So this was the situation. This is the position of the village. It's surrounded by a big river, so you cannot get there by car. And people are living in tents when we arrived, and all the houses were destroyed. And if you want to ship things in, you have to ship it across the river. And if the river level is high, then you say sayonara, you say goodbye, and then you get washed away to Shanghai. And we actually learned a few things from Anna, okay, about how to do this kind of thing. But more importantly, we also talked to the villagers to see how they can do things, what are their techniques, because we cannot teach them something too new. You have to rely on what they know and what they don't know and try to modify how they can build their houses themselves because there is no worker. And we find that on site, they are all rubbish. So we collect all the rubbish, sort them out, and then make sure that the rubbish could be reused to build the house. So the first thing we did was to collect all the rubbish on site and lay them out properly. Ask the local contractor or local technician what they can do and what they cannot do, how they do it, things. And then see how many manpower we have and things like that, organize it socially. Then we designed a few prototypes and we talked to each household, asking them what type of houses they want, okay? And we designed this in such a way that we know we have to separate out, for example, how they keep the pig up there and the cow and things like that. In the past, they just let them run everywhere, but it is not very hygienic. So we decided to build it in such a way that the pigs are somewhere and the mothers is somewhere else and the food are stored up there, okay? So in such a way that they will live a slightly better life. They want their pigs to be with them because they need to look after their pig. So they want to see them. They don't want the pig to be somewhere else. And the toilet is at the back somewhere and not in the past, no toilet. And each one of them is therefore designed slightly differently. And they also need this platform here for drying their crops. So each one of them have a platform like this, okay? So we have to provide spaces that they need, otherwise they will just do some other things. This is the construction that we have developed. We use a bit of lime, okay, to condition the soil, and then also we are not as clever as you guys. We just look at the soil and say, that's good enough for us. That's it. And we don't do this kind of proportion and things like that. We just say, yeah, that's good enough. Okay, done. So we are not as good, but nonetheless, we know that without some conditioning of the soil, it may not stand the earthquake as good. And then we realized that the foundation is very important. So the foundation, we actually built it very carefully with rocks, and a little bit of cement was used, okay, for the foundation. Otherwise, the timbers are from the original house that we use for the main structure. But the more important thing is the bamboo that we use to reinforce the mud at the different levels. Instead of using rock, we use bamboo because they have plenty of bamboo. And then one of the more important thing is every time you come to the corner here, you have to cross brace it with bamboo, so that when the whole building moves, it will be more stiff at the corner. And then also the more important, one of the important thing at the corner is that you should not put a window too close to the corner, otherwise it is the weak point. So these are some of the things that will enhance its seismic resistance, and yet at the same time doesn't cost anything. So, and we also, again, we improve their tools. In the past, their tools cannot pound the earth too solidly. So we improve it, and there are two heads. One is a square one, and one is a round one, okay? And the square one, like what you have done, will compact the soil, but the round one is actually very useful because the techniques they are using is not very good, like that. So, and you need to get the soil near to the shuttering. The shuttering is not like yours, it's very, very good. Their shuttering is like that, okay? So you have to find a way to use a tool which is slightly more flexible so that it doesn't fit exactly like what you guys are doing, but then it somehow will fit, will push the soil to the shuttering when the shuttering is curving and sloping and doing all sorts of things. So we actually developed the tool in such a way that we account for the unskilled labor on site and the very imprecise kind of formwork that they can do. So this is the structural diagram that we use to make sure that all the timbers are sitting on a pad before it sits on the roof and something like that. The corners are all reinforced. So this is the structure and also the material techniques that we use. Now, we did a bit of test to see how strong it can. So we built a concrete frame, and we built different type of wall, and we try to push them to see how they can resist lateral movement. So for each one of them, it will crack in a certain way when it's pushed. So we know which one is stronger and things like that. So we then therefore can select the type of soil mixture and things like that. We also perform a compression test to make sure that we are working with some numbers. And then problem areas that we will find a way to reinforce. So these are some of the structural techniques that we perform on site to make sure. Now the more important thing is that all the houses are destroyed, and each household send one man to the site, and we teach them how to build one house. So this is the first house they learn how to build. And you can see that the house, actually, we start from one side of the house and move to the other side. So these are all rubbles. So when we move, then we use the rubbles and make the house. And as we finish, we will have the house on the original site. The good thing about that is that you don't occupy this new house on a new site, which is their farmland. If you do that, then they lost a bit of farmland, so they get poorer. So we use original material and original site to build up this house. Okay, so these are some of the things that you can see about the timber structure and also the framing, cross bracing and things like that. This is how they embed. And every evening we then summarize what they have done wrong, and then so next day they don't make the same mistake with the villagers. Okay, the first house was built here. Okay, and then once that house was built, then they all go back to their own house, and then a few of them will gang together to build this house, and then they will help each other to build this house and things like that. So they will then help each other in small groups to rebuild the whole house. So the first one, we managed to do it in 3 months, and after 3 months, all the other houses were built. So they know how to do it themselves. We only need to send a supervisor to go there from time to time to make sure that they don't make mistakes. and that's all. So the whole village was rebuilt in about 6 months. And we also designed a community center for them that looks like this. They like dancing. So this is the courtyard for this is the courtyard for dancing, and this is the clinic and the library and the old people community center, all surrounding the dancing piazza. The dancing piazza looks like this. So they will just dance around in circle for the whole day, and then we also at the same time build them a bridge that allow them to go to their village without swimming anymore. So this is the outside of this particular community center. It's 2-story high, and it's about 6 meters, so all ram earth construction. There are other things that we do to supply them with clean water and biogas and toilets and things like that, and also public health education, i.e. If you want to live a longer life, then you have to have some hygienic practice that is good, like not smoking too much. We did evaluation, and you can see that the material cost is almost nothing as compared to a normal cost. And the manpower cost is almost equal. You only need to have 2 chickens to make sure that people are happy after every day to work for your house, okay, and feed them well. And then when you go to help some other people's house, they will feed you with chicken, okay, and they're very, very cheap. And on the last day, if you do the house properly, they give you a pig. Oh, they cut a pig, not give you a pig. So you have a pig, so at the end of the whole thing. So you can see that our house only costs about 10 to 20% of otherwise they will have to build it based on the government's standard. And because of that, the government actually gives them this much money to rebuild. So most of the people in other villages have to top up with all this money before they can rebuild. But ours, they actually pocket and buy a lot of pigs. So they like it very much, so they don't mind. And also we also calculate that our house in terms of performance is much better than other people's house which are more expensive. In the summer, for example, the other house can reach a 45 degree, but ours is very kind of uniform, you can see. And the satisfaction rating is also very high. A lot of people are satisfied with the house. So these are some of the things that we did to convince the government that next time they don't need to spend so much money helping the villagers. They only need to spend this much money and keep the villagers very happy. So the China government have adopted these fundamental principles, and next time if they have an earthquake, they will use this principle instead of the old one that costs too much money and the people don't satisfy. So this is one thing that I think construction can become research, i.e. have an impact beyond the case studies. And it won a number of awards, including the UNESCO award, so we are very happy about our achievement. And I've just been told that both projects has been shortlisted in the Terra award, so I look forward to seeing the result. I hope we were lucky later on in Neon, so therefore I will go to Neon. There are 40 of them, so we may be lucky, we may not be lucky, so we will see how it goes. Okay, but it's very satisfying that the 2 projects are all shortlisted. The third project we are still working on is another earthquake site. This one is slightly more scientific that we are working on. Again, the problem is like this, and the government come in with a very expensive prototype that nobody can afford, only a few people, and they are not very sustainable too. So and one of the problem with that kind of house is that you buy the house and the contractor come and build it for you, and then they will leave. So all the economic benefits doesn't stay in the village at all. So what we are trying to do is say, okay, why not we can train up some of the local villagers to build houses themselves, and next time they can earn a living by building houses for others. So the economic benefits stay in the village. That is our sustainable motive. So we developed a comprehensive technique to help the villagers, not just rebuild the house, but to rebuild the community by giving them skills, by giving them techniques that they can therefore next time help themselves. So we team up with a number of universities like Cambridge on seismic engineering, and this one is on protocol and management, and some of them are on social science, health, and architecture. We call this one university, one village campaign. That is to say, we try to use a university knowledge, a multiple version of it, to help one village and see whether or not we can do something better. And this is on-site discussion about the design. She's from Cambridge, and this one is from local university. He's an earth architect's expert. Now, this area has a much heavier problematic seismic problem. So we try to build it slightly more robustly. So the foundation, in this case, use more concrete. Okay, you can see there's stone inside, but they are a little bit more stronger. They also have some reinforced bar. And then the wall, we try to use some mesh. Okay, and then there are tools that we have adopted from our learning from our French guy, like that. Okay, so it's much easier to pound. You don't need to do that, and it's much faster. And also, it can also compact the soil much better. So as you can see also that you can see our head, our pounding head is circular, so precisely because the formwork is not straight. So these are some of the things that we have to do to adopt to the system. And this is, you see our formwork is a lot less sophisticated than yours. So we have to make do with something slightly less technical. So these are some of these are the lady who is trying to improve the soil and for us with some line. And then some mixing, and then these are some of the wall being finished, and they're pounding the earth, the wall like that here. And the formwork actually, like yours, go up as it move up the house. The window actually are the weak point, so therefore we actually had designed in such a way that we have a timber frame that key into the wall. So the timber frame is actually inserted into the formwork before the earth is pounded. So it has something that using this frame to prevent the cracks from developing easily at this kind of corner. So this is the kind of window frame that we need to insert into the wall. Okay, so you can see that the frames are all part of the. This is we have done two versions. One is the Adobe version, which is this one. The other one is the WAM Earth version. If we want to see which one is stronger and which one is faster and which one is easier. Okay, so this is the house. This is the WAM Earth version, and then this is the Adobe version on one side. And I can tell you a joke about this particular house. After we finish the house, we invite the government officials to come to see the house, to demonstrate to him that actually you can use very little money to build a house which is much better than the concrete house. Then the guy actually doesn't like earth architecture too much. So he picked up a piece of brick and say, what kind of nonsense are you still asking people to live in earth house? They are dinosaurs, they are rubbish, they are history. So forget about them. We should have concrete, we should have something much more modern. Then he threw the piece of brick onto our wall, and the bricks, and the wall, nothing. So he suddenly realized that these are not actually earth wall, they are super earth wall, okay? So and therefore he decided therefore to allow us to continue. And also lately he allows us to write guidelines so that he can do something about it later on. So sometimes these kind of officials are quite funny, and you have to ask them to do some funny things before he realizes he's wrong. We subject the two houses in for shaking tables, seismic. We have a shaking table in one of the local universities. You can see these two houses will be shaken to Richter scale 7, which is very, very, very difficult to achieve. So we can see that actually, to our surprise, that one actually performed slightly better than this one. Don't know why. But then both of them actually survive Richter scale 7, which is quite difficult. So we found that actually there are a few things that we have to make sure before the next prototype that we are building. So we actually, for example, this is the earthquake in the local environment, and this is another kind of earthquake somewhere else. So we actually mimic those different kind of earthquake in the shaking table, and let the shaking table shake to the specification of the recent local earthquake, and also to some other earthquake that has different characteristics, and see how the house perform. So these are some of the different techniques we use to make sure that our two buildings are good. 9 degree is China scale, so it translates to 7, rate 7 of Richter scale, which is quite high. This is the improved prototype that we are building. The form has to be simple. The surround nowadays, we use a much stronger surround at the moment in concrete. So this will allow slightly bigger holes to be made, but yet at the same time doesn't crack the buildings too much. So this is the schema of how the building is made up. And we have a rain beam on top to make sure that the roof sit on it. And the roof is designed in such a way that they are self-supporting, i.e. They are very rigid on its own. So they are not rafters. They are just one system, one triangle, being put onto the roof of the earth house. So the roof form is slightly modified, and we're still building it at the moment. So this is the contractor, or this is the owner contractor, and it's still ongoing. And we are, at the moment, I have already shown you 3 projects. This is another project that we are working on, is to rebuild the entire village of 55 houses. So we are still working on this, so I have nothing more to show. Having said everything that I've said, you can see that there are a lot of people who still live in villages, and we need to find ways to develop simple ways to help these people. So this is how I spend my time doing my hobby. These are some of I have already searched around the world to see different people helping the local villages. You can see Anna is there, you can see here. And these are some of the other people doing different kind of things to help local villages in different way. So I hope that in future we can all gang together as a brotherhood to help the local villages doing better buildings. So this is the team, and the reason why we survive so well is our university president is this guy. He go to site with us, so he don't complain about me not in office. So that's my end of my talk. So thank you very much.